Hello, my name is Grace Wu, and for the past 2 semesters, I did my mentorship under the guidance of Mr. Jordan Parmer at a company called Oseberg, and Mr. Jordan is a software engineer there. And today I'll be mainly talking about the application of SQL in determining consumer product utilization, which was my first project that I worked there. So first, I want to talk a little bit about Oseberg and what they do. So Oseberg is a data intelligence company based in Oklahoma City, and they primarily work with energy information, particularly oil and gas. Basically, they go out, they collect information from state, federal, and county records, and then they organize that information and make it more accessible and easier to analyze, among many other things. This kind of information would be valuable to a wide variety of people. Some of their potential clients could be engineers, geologists, analysts, etc. They mainly cover areas in Oklahoma, Texas, and New Mexico, but they're working on expanding that coverage. So they deliver this nicely packaged data through some of their products. 2 examples would be Sol and Atla. So what is SQL? I was actually mispronouncing it until prior to last week when I Googled it. So if I refer to it as SQL, apologies for that. So SQL stands for Structured Query Language. So it's a programming language that's very popular for managing data in a database system. So I spent a couple weeks learning how to use it. So the goal for this project was to be able to visualize trends in consumer product utilization. So using the data that we have in Oseberg's database, we want to organize it and present it in a way that's easy for us to analyze. So this is where SQL comes in. We used it to query a Postgres database, and I'm pretty sure that just means that it's a database that complies with SQL queries. And then we used Zeppelin, which provided the platform to carry out those queries and present it in a nice way. And by nice way, I mean like graphing it. So how this works is whenever a customer would interact with a feature using Oseberg's product, that action would be stored as a new event in the database with like a timestamp and a short description of what that activity was. So an example could be like every time the customer would use like a search option to find like a specific area to look at, among other things. On the left is like an example, like a picture I found for Zeppelin. You can, once you organize like the data, you can choose what categories you want to divide it in to visualize it. So when you organize that, you get something like this. This is when we organized it into a line chart to show the number of events that occurred by document type in Atla over a period of time. So I'm not actually allowed to share what the data is since it is private to Oseberg, so that's why it's all blurred out. But this is what we got when we organized the data by document type, and that represents the different types of actions a customer performed. We looked at the total number of events for each document type category and looked specifically at Atla, which is one of the products developed by Oseberg. And so Atla is a visualization tool that helps map out and filter data relating to oil. I worked on this project back in the fall semester, so we focused on information given for like time prior to 2019. So I didn't actually like see this particular graph until a week ago. And so what's interesting to note is that you can kind of see how the pandemic impacted the usage of Atla. So as you can see, the amount of usage peaked in January and has been declining ever since. So this graph, you can kind of see the data when it's organized by document type and state, those being Oklahoma, Texas, and New Mexico. And when it's like this, it's a bit overwhelming, dividing your data into too many variables. So it's better to narrow down your scope. So this is when we narrowed it down to just Oklahoma. However, this covers document types that are not just limited to Atla, but could include like their other products. For example, maybe like Sol, like I mentioned earlier. These are the same, but for other states like New Mexico and Texas. So something that you might have observed is that while SQL can be used to determine how much a client uses a product over time, it's still up to us to analyze those trends and identify what the causes of those trends are. So you could test this out by maybe like changing an aspect of the product and seeing how the amount of usage is impacted by that. So this could include like maybe changing the design of the tool or adding more capabilities or maybe trying to improve its overall performance. Back when I did this project in the fall, I saw some trends for 2019, but I wasn't actually sure like what the causes of them were. Um, I assumed that when I left for a winter break, the employees at Oseberg were able to utilize this. And I'm really glad to see now how like the report helps show how cause like COVID-19 impacted their product utilization. So before I wrap up my presentation, I want to talk a little bit about the second project I was working on before spring break. So I was working with GIS, which stands for Geographic Information System. It's a computer system, and like the name suggests, it is used to view, analyze, and manipulate geographical data. This is really helpful for editing data in maps and trying to focus on what you want to see in particular. I was learning how to use the application QGIS. It's a GIS tool, and you can install it on like your laptop or desktop. And like I mentioned earlier, it helps manipulate geospatial data. This is a picture I found on Google. It's an example of one of the versions of the application. So basically you could input your own map and add specific components like lines and shapes and many other things. It's really convenient because on the left-hand side, you can manipulate the layers as you please. If you don't want to see bridges, you can have that option. If you want to change the colors, you can. It's like endless options. You can see how the different types of lines represent different things like bridges and streets. And with the random shapes, they can be used to map out lakes or other areas. For Oseberg's purposes, I'm assuming you can use it to map out areas with maybe oil deposits. So I presume that I was going to be using data from Oseberg to create maps of certain areas in Oklahoma, Texas, or New Mexico to depict these areas with oil deposits. This would be really helpful in deciding like the next place to extract information from and organizing it and preparing it for clients. This could also be helpful for like comparing different areas in those states. So yeah, that's about all I did. So I would like to thank Mr. Jordan Parmer for dedicating his time to mentoring me and overseeing these projects. And I'd also like to thank the other Oseberg employees for helping me understand more about what they do at Oseberg, and also to Dr. Richards for organizing the mentorship and taking time out of his day to drive me to Oseberg every week. And yeah, any questions?
Thank you, Grace. Good job. Um, you mentioned that the data that the software uses comes from like just state and county records, right?
Mm-hmm.
But how does it get in there? I mean, is it did the states just send like a spreadsheet and then you import that into the file, or is it a more manual process where someone has to go through a bunch of documents?
There's actually like, correct me if I'm wrong, my mentor is here, but I'm pretty sure that it like varies. So there is like for a while there it's like a manual way to go out and like physically have to go collect them. But I'm pretty sure there's other resources like you mentioned earlier, like having it more conveniently like on a spreadsheet or something and being able to get that information.